Now, obviously here I have a story again, but it doesn't bother me because I see that I have equations and I have a graph, and the graph consists of points. So that all is good. But let's take a look at the story and just make sure there's nothing weird going on. A chemist conducts an experiment by measuring the temperature T of a solution in degrees Celsius m minutes after a reactive agent has been added. Over the interval in the graph, the change in temperature is nearly linear. Which of the following equations best models the line of best fit? So one thing to note, because this technically is a scatter plot, the dots themselves do not matter. So I know we talk about points and equations, but when we have a scatter plot, there's basically two kinds of points, and we're almost never going to take the dots. And I don't care if the dot is close to the line or not. The line is what they're asking about. That's the line of best fit. So I want the equation of that. So if I want to get some points, I take points that are on the line. And so I don't care. Like, I don't, like, here, some people are going to go to this point because they're like, oh, the dot is on the line. Could not care less. Ignore the dots. The dots have nothing to do with it. So I'm still going to plug points into equations, and I'm going to start where I always start, which is down here. Okay, and that, not the dot, the point where the line hits the axis, that's my y-intercept, kind of looks like 30, maybe a little bit bigger than 30, but something like that. Now, the best thing about plugging in m is 0 is all these terms go away. And then basically I can just look at the end. So this is me being very comfortable with the properties of 0. This is something also that's very useful when we're doing plug points into equations. Since a lot of our points are going to be 0s and 1s, we really want to be comfortable with those rules. So you can see though, 31, 32, even 38 well, 38 is kind of close. Negative 40 is not. So I can get rid of D. I know that that's not right. 38 is probably wrong as well. That looks more like where the dot is, but it's close enough that maybe I'm a little nervous getting rid of it. So just from the y-intercept, I don't exactly know what my answer is. And so we really shouldn't pick an answer here because it's just too close to call and we might just be seeing it wrong, So let's bring back these pieces so that we can now use them, because all I have to do here is pick another point. And you can go really anywhere, but generally speaking, when I try the y-intercept and it doesn't work, a good way to kind of deal with that is to move further away, because if, at least for a line, if it's something else, that this doesn't necessarily matter, but for lines, that really just means that the slope is the thing that matters. I am not going to calculate the slope using rise over run or the slope formula. I'm just going to plug a point in, but the further I go away from the y-axis, the more that slope kind of matters. So I'm going to pick, something like this. So this point here, 40 is the x, and the y looks like 170. Okay, so something like that. I'm still estimating, but there you go. Now, as I plug that in, I wouldn't write this on my page because I could just do this in the calculator, but just to show you, 2 times 40 plus 31, that's basically what I'm going to do as fast as I can type in my calculator, making sure I don't make any mistakes. So honestly, 2 times 40 I can do in my head, so that's 80. 80 plus 31 is 111. Now, remember, we're trying to get 170. 111 is pretty far from 170. I feel pretty good crossing that out. If it were like 161, I might keep it, but 111 is way too far off, so that doesn't seem right. Now, for 3.45 times 40, I am going to just use the calculator. 3.45 times 40 is 138 plus 32 is 170. Hey, I wasn't actually expecting it to be dead on like that. I thought it'd be like 169 or something, but hey, this seems pretty good. But I should still make sure that C doesn't work because it is possible that something else is going on. You really just always want to have definitive proof that you've either proven your answer right, or in cases like this, also proven everything else wrong. So 4.24 times 40 plus 38. And I kind of already know it's going to be wrong because I just know 4.24 times 40 is already going to be much bigger than 170. Well, that's 169.6, but don't forget plus 38, we get 207.6. Too big, so that's gone, and B is the answer. And that's it. Yeah. You could have found the slope here. Feel free to knock yourself out if that's what you really want to do. But if you're doing that I think is more risky. The slope formula inherently has greater risk because you have to have 4 different numbers in exactly the right place because there's 2 points, right? So that's 4 numbers in exactly the right places. You've got a fraction, you've got negatives to deal with. It can get messy. Whereas if we're plugging points into equations, we really only have to deal with 1 number in the right place, right? Because the y number is off on its own. So we're not really plugging that in so much. We're more kind of comparing the y value that we would generate from our x to the y value that the point is. So in this case, the 170. So that's great. To me, that's mentally easier. It's safer. You want to plug things in, but if there's a path that has fewer things moving around, fewer moving parts, that's the better path. So that is exactly how I would do this on the real test. I'm not just showing you this to promote a strategy. This is exactly what I would have done. I would have done it much faster because I wouldn't have had to talk through it all. But this is a question that should take you 45 seconds, basically as long as it takes to plug things into a calculator. So maybe even less than that.